While making some delicious treats, we are going to exhibit how these cookies are special cookies that exhibit the process of photosynthesis that occurs normally in plants. First, we must have our starting inputs.
To begin photosynthesis, you need carbon dioxide, water, and sunlight.
We are going to use this butter to represent water. We're going to see that this water in the non-cyclic electron pathway, aka light reaction, of photosynthesis begins when a photon of light excites the pigments in photosystem 2, which we represented with the sun hitting our bowl, and releases an electron to the reaction center. This electron is replaced by broken down water, which is broken up into O2 gas and hydrogen molecules, which release electron molecules into photosystem 2, which goes to chlorophyll A at the reaction center.
Now we're going to add some sugar to our photosynthesis reaction, and this sugar is going to act as our hydrogen molecules from the broken up water, and we're also going to add some vanilla that's going to represent oxygen. When the vanilla is cooked and baked, it's going to release a really good smell, which is going to represent the oxygen being released from our photosynthesis reaction.
Now let's take a more detailed look at what is really happening in our photosynthesis cookies.
The electron, represented with sugar, travels down the electron transport chain through a series of redox reactions to photosystem 1. Photosystem 1 releases the electron to NADP reductase, which we will represent with Jordan, that takes NADP and combines it with a hydrogen ion from the stroma to produce NADPH that will go into powering the Calvin cycle.
This combination of NADP plus hydrogen into NADPH is represented in our cookies by the eggs, which have two parts coming together, the egg and the yolk.
The flow of electrons throughout the ETC enable the carrier proteins to force hydrogens, our sugar, against their concentration gradient and into the inner thylakoid space from the stroma. This high concentration of hydrogen ions allows hydrogen ions to go through ATP synthase and combine ADP and a phosphate to produce ATP through phosphorylation chemiosmosis.
The ADP plus phosphate and ATP is represented in our recipe by our flour and baking powder mixture. These ingredients will power the cycle that will happen in the oven. All this that happens in our bowl occurs in the light reaction. Now, let's take a look at what happens in our oven, otherwise known as the Calvin cycle.
The next part of photosynthesis is the Calvin cycle, and it takes place in the stroma, which we're representing with our oven. So first, carbon dioxide is going to come in from the air and mix with a carbon compound, which in this case is RUBP, and this represents the first step, which is carboxylation. The second step, which is reduction, we utilize the products of the light reaction ATP and NADPH to provide our energy and our hydrogen to make our end product, which is glucose, aka our delicious sugar cookies that we're going to get out of the oven. Our last step is regeneration, which we're putting in more ATP so that we can remake RUBP to keep the cycle going.
Nice to meet you, where you been? I could show you incredible things. Magic, madness, heaven, sin. Saw you there and I thought, oh my God, look at that face. You look like my next mistake.